In our previous video, we looked at an overview of RecyclerView. So in this video, we're just going to jump right in and do a hands-on demonstration of RecyclerView in Kotlin. This is a look at the application that I have right now that I've created in a series of previous videos. Normally what I would do, and what I did on the Live Plant Places application, is I activated this open button to show a list of specimens. That would require creating a new activity and a new layout, several other things that would extend this video by about 10 minutes or so. So I'm going to abbreviate things for this video. I'm going to make use of this little image component that I'm not currently using in this application. I'm going to put a RecyclerView down here, just with the knowledge that I would eventually refactor it and put it into its own separate screen. Take that for what it's worth, though. A lot of times it's a good idea to try to make an app that's one screen. But nonetheless, let's jump right in as promised. So one of the things that we need to do is we need to modify our build.gradle file under app and add the RecyclerView component. Naturally, check for the latest because I'm just picking one that I have that should work with the dependencies that I have, but nonetheless, by the time you watch this video or with your project set up, it might be a little bit different. So we go ahead and we add it and we sync, make sure everything's good. And a quick peek at the build log, and everything is successful, so it did work as promised. Now I'm going to go to our layout. And we see here we have an image view that I want to remove and replace with the RecyclerView. Sometimes I find it easier just to go in and edit the XML directly. So I'm going to go ahead and take out that image view and then save. And now we're going to add the RecyclerView. I pop back to design view just because it is a constraint layout, and sometimes I do like doing that using the WYSIWYG editor. So nonetheless, you see we have RecyclerView here now, which is a good sign. It indicates that our import was good. So I'm going to go ahead and drop this, and it looks like it found the constraints naturally, but I can, probably a good idea to zoom up and grab these. But nonetheless, we have our RecyclerView there now. I'll zoom up a little bit just so I can go in and go ahead and add these constraints so it feels a little bit better. So, okay, now our RecyclerView is occupying this entire screen. Let's go to attributes and give this an ID. We'll just call it maybe Specimen Recycler. A lot of times I go ahead and do a match constraint on this as well, just to make sure we're taking advantage of the additional real estate that we'll have in a different form factor. So a lot of these other things don't make sense to make taller, but the RecyclerView does. So we go ahead and do a match constraint on that, and then I save. Now, Specimen Recycler is what we're calling this. Let's go back to our let's run back to our activity, which in this case is called GPS a plant, and I'm going to go up to the onCreate function, give us a little bit more room here, and we'll say Specimen Recycler, and then a dot. And one thing to remember here is we're using the really cool Kotlin extensions, which means we don't have to do a find view by ID if you're used to that from the Java days or anything like that. It just knows that this is the identifier that we used for that RecyclerView on our layout. So it says, okay, yeah, I know who you are. So we'll invoke hasFixedSize. And then we'll say Specimen Recycler again. And it says, okay, yeah, I'm kind of getting the hang of this. We'll say Set Layout Manager. And then we'll say Linear Layout Manager this. And then we'll say Specimen, we'll go up and import that. There we go. We're creating a new linear layout manager in line here if you wonder what's going on. So in Java, we'd have the new constructor. Kotlin, not necessary. Specimen Recycler, and then item animator equals default item animator, just like so. So just doing a bit of prerequisite setup here. Okay, that gets our RecyclerView configured. We still need to do the adapter and the ViewHolder and a layout. Now the layout's a little bit tricky because for the layout we want to think of what will represent each line in the recycler. So we're typically facing some kind of object, and we want to think, how do we want this object to look? We could go with, a boring old text list, but we could also think about something like an embedded image, something like that. So let's just go ahead and make a really simple layout. I'll go back over to the menu here. We'll say Layout. We'll give a quick view to what we already have. Now I'm going to right-click, and we're going to make a new layout resource file. And for this one, we'll just say Row Layout. Since we're going simple, we don't need this to be a constraint layout. A linear layout will be just fine, so we'll just start typing linear layout, and we choose OK. And remember that this is going to get repeated. We're going to see one of these for each item that we have in our recycler view. So take a quick look, and I'll tell you what, let's change this from vertical to horizontal. Everything else looks pretty good there, and choose a save. And now let's go back to design. Just collapse a couple windows so we can zoom up and get a better look at this. And now I'm going to take image view and I'm going to drag this over to the left. It's going to ask me for a default image. I can just find something like that, like this launcher icon that I used earlier. Yeah, just something that we would theoretically eventually put an actual image of a plant there. So next we'll do a text view. Remember that a text view is kind of like a label. It's read-only text. So we do our image in our text view. And for the text view, I go over to attributes, and I'm going to call this something like LBL specimen info. And for the image view, I'll select this, and I'll call this one IMG specimen thumbnail. So we'll give it those two things, and I'll save. On the text view, we also want to remove that text that's in there because text view isn't really doing anything for anybody. So we do it just like so. We can play around with layout weight. We could give these both a weight of 1, so they take up roughly equal space. We can finagle that later. Not terribly concerned about that for this demonstration. So now at least we have a layout, and we are ready to proceed and add the adapter and the view holder. Back to our activity now, and we want to add this view holder within our GPS a plant activity. So before this closing curly, not within another method though. So what we'll do is we'll say class and specimen view holder. Now this is going to have a constructor that's going to accept a view. So we'll say item view and then colon view, so of type view. This view essentially represents our layout that we just created. So from this view we can grab components off of it and we can populate those components. In our case, those components will be the image view and the text view that we just added. Okay, our class needs to extend from something called RecyclerView, just like so, .ViewHolder. Now, RecyclerView ViewHolder has the same constructor requirements as the class that I'm creating right now. So we need to pass item view straight up into this constructor. Now let's open curly and close curly to create our class. And let's do an init block. So init, and we'll say item view dot find view by ID. Now in this case we're pulling these components right off of that layout that we just created a few moments ago, the thing called row layout. The thing called row layout is represented by this variable called item view. So item view, find view by ID, and then we'll say image view. And for this one, we'll say r.id.img specimen thumbnail. Remember that? Okay, looks like we need to import our image view, so we'll go ahead and import that. Let's save this to a local variable. So we'll say img specimen thumbnail, which is maybe a little bit long-winded, but nonetheless, just like so. Now, of course, IntelliJ is going to yell at me. We'll do the Alt-Enter, and we'll say create property, just like so. Ah, magic. And there we go, looking good. Okay, let's do this one more time. We'll say item view dot find view by ID, and this time we'll say text view, and we'll say r.id, LBL specimen info. That'll work. And once again, Alt-Enter to do the import. And let's call this one again LBL specimen info equals, just like so. And once again, IntelliJ is going to yell at me, so Alt-Enter, and we'll say create property, just like so. So now we have these properties both defined. And once again, these are the items that we're pulling off of that row layout. And so these are the items that we're going to populate with our specimen details. Now, to populate these with our specimen details, we need to do a couple of things. First of all, we need to make an adapter. The adapter is what is kind of a go-between between our data and what the user is going to see. So let's go up above here and let's say class. So notice once again, I'm within the activity, but I'm not within another class or within another method, but I am within that activity class. So we'll say class specimen adapter, and then colon, and then RecyclerView.adapter. Notice that this requires a ViewHolder as a generic type, so that's why we did the ViewHolder first, because now we can pass in Specimen ViewHolder as the generic identifier, generic type for this specimen adapter. Open curly and close curly. Okay, implement members, that works for me, so it's going to implement some abstract methods here. And if we take a look at these abstract methods, we'll see plenty of JavaDoc here. Lots of good things going on. Looks like I might have missed a few. Okay, there we go. We'll just pick the rest and choose OK. Okay, so get item count and on bind ViewHolder and on create ViewHolder. These are the things that we need. Let's start with the one that we can do, which is the on create ViewHolder. So I'll go ahead and take out the to-do, and we'll say layout inflator dot from parent dot get context. Oh yeah, context will work even better. And then we'll say, we'll go ahead and do our alt enter there. And then we'll say dot inflate. Now inflate's a little bit tricky because we need to have a layout or a reference to a layout. Because we're using that r.id thing, it's going to be an integer. So let me just put in here, we'll say item layout, and then false is a flag attached to root false. So item layout says, gosh, I don't know what this is. So let's see if I alt enter. Let's say create property item layout as a constructor parameter. That's even better. That's going to make things a lot easier on us. So item layout, and we will give it a type of int, makes sense. And let's see if I'll take that. That looks good. And then we'll go ahead and choose refactor. Now inflate requires one more item, which is our view group, which we have passed into this method called parent. So we can simply say parent, just like so. And now inflate is happy. One more thing that we need to do is actually create our specimen view holder. So if we take a look at our specimen view holder, well, guess what it requires? It requires a view. The good news is the view is what gets returned from this chain of events we have up above. So we'll say view equals, just like so. And then we'll let IntelliJ do a bit of magic for us here, and we'll say, just create this as a local variable. That's fine. Now, we can say return specimen view holder and take a look at what it's requesting here. It's requesting a view, and we pass in our view, just like so. And so now the on create view holder is complete. We have a few more methods that we need to take care of. One of them is the on bind view holder. That one's going to be a fairly long one. Another one is an item count. Okay, for an item count, we're going to need some kind of collection. Now remember, the role of the adapter is to bridge the collection of objects or DTOs with the visual representation in our recycler view. So it makes a lot of sense to add this collection into our constructor signature. So we'll say val specimens colon and then list specimen DTO is a generic identifier, and then a comma. So our constructor is now accepting this list of just plain old Java objects that it's going to show in our layout. So 2 parameters now. While I'm here, I did notice one typo I need to take care of. Because our adapter is extending from RecyclerView.adapter, I need to add the open and close parentheses to indicate a constructor on that RecyclerView adapter. And with that, the line now compiles. Okay, next thing that we need is we need to figure some way to have a collection that we can pass to this adapter. So let's go up towards the top of our class. Give ourselves a bit of space, and up here we can declare private var all specimens equals array list specimen DTO. Very similar to what I just put down in that constructor signature, but we're using an array list here as a concrete type because we're essentially creating an object out of that, where list is an interface type. So we now have declared a collection. We'll still need to populate the collection, and we will need to pass the collection to our adapter. So let's take care of that part now. Let's take care of passing the collection to our adapter. I'm going to go into my onCreate method, and we'll see down here we have a Specimen Recycler, and there's several things that we're configuring on that Specimen Recycler. Remember that Specimen Recycler is that RecyclerView layout. So let's do one more. Let's say Specimen Recycler, and then we'll simply say dot adapter equals, just as we assign an adapter, and then we'll say specimen adapter, and we'll pass in the collection we just created called all specimens. There we go. And we also need to pass in a layout, but which layout are we going to pass in? Well, remember this layout that we created a bit earlier, which represents one individual row in our recycler view. That's what we want to pass in, because we want to populate each of these rows with an item from our all specimens collection. So we'll say r.layout, and then we'll say dot row layout, just like so. And now we are creating our specimen adapter. Okay, great. So let's go back down to that specimen adapter with the constructor that we've created, and we know we're now populating. And now we can start to fill in some of these methods. Let's take a look at get item count. Well, this is easy. Take out the to do and say specimens dot size. We'll say return specimens dot size, just like so. And so now we have fulfilled this method or this function by using the specimens collection that's getting passed in through the constructor call to specimen adapter. Now we still have a few more things that we need to do. I've created this collection. I've not populated it yet. In the next step, I'm going to start populating the collection, and this is where my example might differ from what you want to do, just because you might already have a collection that's populated, or maybe you're getting it from JSON or something like that. Well, in my case, I'm getting a collection from Firebase by implementing this value event listener and this onDataChange function. So onDataChange gets called when we first start up the application, and also anytime the data changes on our Firebase Cloud database. So this function gets called, and it gets called with a collection of children that represents the data on Firebase. Right now I'm just showing a toast, which isn't adding a whole lot of value and frankly can get a bit annoying to the user. Let's go ahead and take this away. And what we'll do inside of here is we'll say it.getValue. Now what's it? Well, in an iteration, it is the current object we're iterating over, and we're iterating over essentially a data snapshot, which is that reflection of what's in Firebase. So it.getValue, what we pass into here is an indication of the actual object type that is stored in Firebase. And that object type is a Specimen DTO. So we say Specimen DTO. Now it's a little funny syntax in Kotlin because we do : and then class.java. And it simply says, I know that I have saved Specimen DTO objects in Firebase, so I would like to receive these back as Specimen DTO objects. Now we can save our specimen equals it.getValue, just like so. And then all specimens, remember what that is? That's the collection we made as a class level variable or field or attribute if you prefer, just a few moments ago. So our array list, all specimens.add, and then specimen. And it's a little bit tricky if I leave it just like so because it gets confused about the nullability of this. You can see the question mark down there. So I simply have to double exclamation to say it's okay. I trust this, that it's not going to be null, and I'm willing to take the risk that it is. So at this point, we're populating our collection. Now here's an interesting thought. This function onDataChange is going to be called anytime our Firebase database changes, anytime that data inside changes. So we kind of need to nudge the adapter to say, hey, the data model that you are representing has changed. After this children for each loop is complete, let's do that. Let's say, Specimen Recycler .adapter, and then we'll say .notify dataset changed, and that just kind of pings it and says, hey, that collection's changed. I'd like you to represent this in the view. Great. Okay, just a couple more things we need to do then. Let's go back down to our adapter. We have our onBindViewHolder function. We have it to do there. Let's go ahead and take care of this. Now, look very closely at the function signature. We're receiving an instance of our ViewHolder. Remember, the ViewHolder is going to grab our row layout and populate it with one object at a time. We also have this thing called position. The position represents the position in our grander collection of the object that we want to represent in the ViewHolder. So we'll start like so. We'll say all specimens, or actually, sorry, specimens dot get position. Remember that we're within our adapter at this point. It's an inner class, but we are within the adapter, so the collection at this point is called specimens. So specimens.getPosition, and that will return to us a specimen object. So var specimen equals specimens.getPosition, and then we'll say holder dot, well, somehow we're going to need to tell the holder that we have the specimen that we want it to represent. So we'll make a new function on the holder called update specimen, and we'll pass in our specimen object. Now, of course, it's going to be red at the moment because this function does not yet exist. A little bit of Alt-Enter, and we can say create member function, just like so. And notice in our Specimen ViewHolder, Android Studio was kind enough to go ahead and fill out this function for us. We simply have to complete the details. So from here, it's actually fairly straightforward. And I'll tell you what, I'm not really keen on having this all the way at the top. Let me move it down just a little bit so it kind of makes a bit more intuitive sense. No real difference, just a bit more readable with it having lower. So I would love to update the specimen thumbnail, but in this application, we're not capturing an image of the specimen. All we're doing is capturing some information about the specimen. So for a simple example, we're just going to update this LBL specimen info component. Let's say LBL specimen info question.text equals specimen.toString. So a really simple operation. We're saying take the specimen that was handed to us, the one at the current position in the list, get a string representation of it, and update the LBL specimen info text view inside of our layout, inside of our recycler view, with the specimen's string information. Now I also made one little tweak to the layout. I changed the layout height to wrap content so it will take only what's needed. I paused the video for just a moment and I've deployed the application so we can see the final look and feel. And take a look at this. We have our application, and where the image used to be, we now have this recycler view, and I realize that the text is a little bit small to read and the image is the same thumbnail, but nonetheless, we see the recycler view indeed does work because I can scroll up and down. And as I'm scrolling up and down, it's simply taking the text from the items that are not visible, and it puts them into the components on the layout that are visible. The very first time I made an app, it was very similar to this one, and the recycler view did not yet exist. And so it had to create these UI components for every single row. And the rows in my app were plants that I had GPSed. Over time, I'd ended up GPSing several thousand plants, and so it had to create those view components, the image view and the text view, for every single plant. But you see, with the recycler view, it only needs to create them for what we can see. So here, about 5 or 6, plus or minus a couple on either side, so that it can handle scrolling. If we take a look at the total, I count 5 here, and then about 3 more, so 8 total. Just to test things out, let me go ahead and put in a new plant. We'll say Southern Magnolia. We'll go Southern Magnolia, that will work. And we'll give it a location of University of Cincinnati. Description, April 2019. And then we'll choose Save. It is going to hit a series of breakpoints that I have here, so we'll go ahead and fast forward through those. But we do see the breakpoint I just fast forwarded through was saving the data to Firebase, and we almost immediately heard back from the on data change, which is hearing back from Firebase. I'll go ahead and F8, F9 through that one, let it go. You notice that it hit the notify dataset changed. So let's go back and have another look at our application now. And I will say I am seeing what I want, but I'll confess I did notice a little defect that I can go back and create. I was expecting to see 9 elements because before I had 8. I'm actually seeing 18 elements, or probably 17 elements. And so the notify dataset change did work perfectly. But what I missed that I can go back and correct is every time this function gets called, I'm adding specimens back to the original collection without clearing out the collection. So it might be a good idea just to clear out the all specimens array list up here each time this gets called so it starts anew. But nonetheless, we do see that the recycler view is able to adapt, and receive new specimens and show those new specimens when we invoke this notify dataset changed. So RecyclerView, the adapter creates our ViewHolder. We get an individual layout item from the RecyclerView, and then the job of the adapter is to take these items from our collection, pass it to the ViewHolder. The job of the ViewHolder is to populate each of the row layouts individually in the RecyclerView. So I hope this video has been helpful, and I look forward to reading your comments. Thank you.